Today's lesson is about simple and compound probability. It is Common Core Grade 7 Standard SP.8a. Well, first, what is probability? Well, probability is the ratio of favorable outcomes for an event to occur divided by the number of all possible outcomes for the event to occur. Now, we write this algebraically as P of A, so that's probability of an event, and that is equal to the number of favorable outcomes divided by the total number of possible outcomes. Let's do this. A bowl contains 2 red chips, 4 blue chips, 3 yellow chips, and 1 green chip. 1 chip is randomly drawn. Find the probability of drawing a red chip. The probability of red. Well, how do you do that? Well, on this one, first of all, let's talk about our favorable outcomes. Well, that's red chips, and there's 2 of them. So 2 is going to be our numerator when we write that fraction that represents the probability. And you always divide by all the outcomes. Well, we've got 2 red, 4 blue, 3 yellow, and 1 green. So that's 10 total outcomes. So when we write the probability of just drawing a red chip, it's how many reds we have, which is 2, divided by all chips, which are 10. But 2 divided by 10 reduces. That is the same thing as 1/5. So that means out of every 5 chips that you draw, 1 will be red. One thing we need to talk about is probability can actually be expressed 3 different ways: a fraction, a decimal, or a percent. All 3 of these are equivalent statements, and all 3 of them mean the exact same thing: the chance of something happening. So if you write 1/5, that means 1 in 5 chances you're getting what you're looking for. But 1/5 is the exact same thing as writing 0.20. That means the exact same thing. And 1/5 and 0.20 mean the exact same thing as 20%. All of these are 3 different ways to write a probability. Another thing we need to talk about is the probability of dependent events. Now, what is that? Well, a dependent event is 2 or more events in which the outcome of one event affects the outcome of the other events. In other words, whatever happened second depends on what happened first. So if 2 events are dependent, then the probability of both events occurring is the product, which means you multiply the 2 dependent events. So the probability of A times the probability of B is the same thing as the probability of A and B. The probability of 2 dependent events can depend on a replacement or non-replacement of the object. For example, if a bag contains 4 red marbles, 6 blue marbles, and 5 green marbles, 2 marbles are randomly drawn from the bag and replaced after each draw. Find the probability of drawing a red marble and then a green marble. So what does replaced mean? That means you pull it up out of the bag, then you drop it right back in after you look at it. So that means every time you draw, you have the exact same number of marbles. You're starting with the same amount because you keep dropping it back in after you observe it. So let's do like the probability of red and green with replacement. So we're dropping them back in the bag. Well, how do you do that? Well, with replacement, what that means is this. Well, first of all, we have 4 red marbles, 6 blue marbles, 5 green marbles every single time. So there's 15 total outcomes, 15 marbles. So the probability of red by itself is 4 out of 15. 4 red and 15 total. Then the probability of the green marbles would be, well, there's 5 green marbles and 15 total marbles, so 5 out of 15. But that reduces. 5/15 is the same thing as writing 1/3. So if we're doing the probability of red and green, so we get a red one, drop it back in, the next one we get is a green, well, what's the chance of that? Well, these depend on each other. And so on this one, what do? Well, you multiply those 2 probabilities. So 4/15 times 1/3 is a total of, remember fractions multiply straight across. So 4 times 1 is 4, 15 times 3 is 45. So the probability of red and green is 4 out of 45. Now this problem is a very similar setup, but it's a little bit different. What do I mean by that? Well, we're still starting with 4 red marbles, 6 blue marbles, and 5 green marbles. Still going to draw 2 marbles out randomly from the bag. But This time we will not replace after each draw. Now, what does that mean? That means when I draw that red marble out, I'm going to set it aside. I'm not going to put it back in the bag for it to be possibly drawn again the next time. So what does that mean on this one? Well, this is called probability of red and green, but without replacement, because we're not going to put that marble back in the bag. Well, how do you do a problem like this then? Well, the start is very similar. The probability of red, well, there's 4 red marbles out of 15 total, so it's 4/15, just like we did on the last problem. But here's where it gets a little bit interesting. So the probability of green, you got to realize we are now taking that red marble out, setting it aside. So what is the probability of getting a green marble? Well, there's 1 less marble to choose from, because now instead of 4 red marbles, there's only 3 red marbles. So instead of 15 total marbles to choose from, there's only 14 marbles to choose from. So the probability of green this time is only 5 out of 14. So that's what the probability is. So how do we find the probability of red and then the green? Well, you multiply, and we do the 4/15 times the 5/14, and whenever you multiply straight across on fractions, you're going to get a total of 20 divided by 210. But that reduces. 20 divided by 210 reduces to 2 out of 21. So 2 times out of every 21 times you try, this will happen. You'll get a red marble, then a green marble. The other 19 times, something else will happen. So that's how you do one without replacement. So with replacement means you drop the marble back in, you still have the same number of marbles to choose from. Without replacement means you pull that marble out, set it aside, so every time thereafter, there's 1 less marble to choose from. Be very careful about this with problems because they go back and forth. So be very careful to see whether it is replacement or non-replacement. Now let's try that similar setup again about replacement and non-replacement. So our problem this time is a bin contains 8 blue chips, 6 green chips, and 2 orange chips. Find each probability when randomly drawing 2 chips. Well, on problem 1, we're going to find the probability of blue then orange, and we are going to replace the chips. So we look at them and we put them right back in the bin for the next drawing. On problem number 2, we're going to do the probability of green, then orange, then green without replacement. So when we draw that green chip out, we set it aside. We do not put it back in the bin. Same thing with the orange, same thing with the second green. So remember, we've got 8 blue, 6 green, and 2 orange. Let's work these 2 problems. So first, the probability of the blue and the orange with replacement. Well, the probability of the blue is, well, how many total chips are there? Well, there's 16, and 8 of them are blue. So it's 8 out of 16, but that reduces. That reduces to 1/2. So 1 out of every 2 times you draw, you're going to get a blue chip. Now, how do we do the orange? Well, the orange, again, we have 16 total chances, total chips in there, but only 2 of them are orange. So 2 out of 16. But that 2 reduces. 2 out of 16 reduces to 1/8. So the probability of blue then orange, well, what do? Well, you multiply those probabilities together. So you do 1/2 times 1/8, and that is a total of 1/16. So out of every 16 times you try that, 1 time it will happen where you get a blue, then an orange. Now that's with replacement. Now let's do problem number 2. This time we want to get a green, then an orange, then a green, but we are not going to replace the chip inside the bin. So realize we'll have 16 the first time, then 1 less for the orange, 1 less even still for the next green. So how many green chips do we have? Well, we have 6 of them. So 6 out of 16, well, that reduces. That is the same thing as 3/8. So we've got the first green chip. Now what about the orange chip? Well, this time you got to realize we do not have 16 chips to choose from because we got that green one, we set it aside. So we only have 15 chips to choose from, but 2 of them are orange. So 2 out of 15, and that does not reduce. Now the next green chip. Well, this time, again, we got that orange one, we set it aside. Just before that, we got the green one, we set it aside. So now there's only 14 chips to choose from, and now there's not 6 green ones, but only 5 because, again, we're setting it aside. It's not going back in the bin. So we have 5/14 chance of getting that second green chip. So in order to find green, then orange, then green, we take all these probabilities and multiply them together. So it's 3/8 times 2/15 times 5/14. Well, if you multiply everything on top together, you will get 30. Multiply everything on bottom together, and it's 1,680. But that reduces. Use your calculator to help you on that. And if you do that, that means you can get green, then orange, then green only 1 out of every 56 times that you try on average. That's what probability is, and that's how you do problems both with replacement and one like this without replacement.